To this point, the only way we know how to solve quadratics is by setting aside equal to 0 and factoring, and then using the zero product principle to solve. We're going to use another method today called completing the square, but in order to do that, let's take a look at some past knowledge first. We've had situations where if we have an isolated squared term and a constant on the other side, we can go ahead and square root both sides and get ourselves an answer. So if I square root both sides, because it's an equation, whatever I do to one side I can do to another. The square root of x squared is just x, and we said whenever we square root both sides of an equation, we have to take the plus and minus the square root of 144, which is 12. Now notice in the second example, we have the same situation. We have an isolated term squared equal to a constant. So again, I can square root both sides of the equation. I'll write my plus and minus in first. And if I square root a squared term, it's just that term without the square. And equal to plus or minus square root of 49, which is 7. So really, if I isolate x here, I have x equals negative 1 plus or minus 7. And negative 1 plus 7 is equal to 6. And negative 1 minus 7, minus 7 is equal to negative 8. So I have two answers of 6 and negative 8. So we're going to use this concept in some sense to what we call complete the square. You'll notice in this example, we don't have an isolated term squared equaling a number. Clearly, I could set aside equal to 0, hopefully factor and solve. But if I did that, let's just show you what that would look like. I would get x squared minus 6x minus 1 equaling 0. And this wouldn't actually factor. So that process isn't going to help us out too much. But I noticed that x squared minus 6x plus 9 factors. What multiplies to positive 9 adds to negative 6 is x minus 3 and x minus 3. And that's equal to 10. This is x minus 3 squared equaling 10. Now notice here, I have a situation where I have a squared term isolated and a constant term. So now I could actually square root both sides and get the square root of a squared term is just x minus 3 equals, there's no simplification of the square root of 10, so I'm going to leave that as the square root of 10. And then if I isolate x, I get x equals negative or positive 3, plus or minus root 10, and that would be the solution for this quadratic, even though it doesn't factor. This would also mean that the x-intercepts of this parabola, if I were to set that equal to 0 on a graph, would not be integer numbers. So now let's talk about this concept of completing the square. So in order to complete a square, which basically means get an isolated squared perfect square term on one side and a constant to another side, are as follows. The first step is to make sure your a term has a coefficient of 1. So a is the term in front of the squared term, and then it does have a coefficient of 1. So this is checked off the list. Then we want to isolate the variable terms. Well, right now I have a 1 with these variable terms, so they are not isolated. So let's go ahead and do that by saying x squared plus 8x is equal to, and I'm going to subtract 1 from both sides, so that equals 13. So now I've done the second part of this list. Then I want to find half of the b term and square it. So my b term is 8. I'm going to take half of that, and I'm going to square it. And that gives me 4 squared, which is 16. So I've done that. Next, I'm going to add that new term to both sides of the equation. So I have x squared plus 8x plus 16 is equal to 13 plus 16. Notice I've added it to both sides of the equation. And also notice what I've done. I've now taken and made a perfect square term on this side because this is the quantity of x plus 4 times x plus 4, and this is 29. Next, what we're going to do is make sure we factor that, which I did. It gets me x plus 4 quantity squared is equal to 29. And now we're going to solve this because I have an isolated squared term, just like we have our previous examples. So I take the square root of both sides, get x plus 4 is equal to plus or minus the square root of 29. Since that doesn't simplify, get x equals negative 4 plus or minus the square root of 29, and the problem solved. So once again, important to know these steps in order to know how to complete the square. Let's do a few more examples. We're going to find a value of c that makes a perfect square trinomial. Basically what I need to know is I need to know that that first term is 1, which it is. I take half my middle term, or my b term, and square it, and I should get a perfect square trinomial. So half of 10 is 5, squared is 25, and if I have x squared plus 10x plus 25, that better be a perfect square. What multiplies to 25 adds to 10, that's 5 and 5, so that's x plus 5 squared. So my c value, 25 in this case. Now we're going to go through and do the whole process and solve this quadratic by completing the square. So first I have to isolate, well, first I have to find out if I have a coefficient of 1 in front of the x squared, which I do. Second, I'll isolate the variable terms by subtracting 24 to both sides. Then I'm going to find half of my b term and square that. Half of 14 is 7. Squared is equal to 49. Then I'm going to take and add that to both sides of the equation. So that's x squared minus 14x plus 49 to the left side, and negative 24 plus 49 to the right side. Notice this is x minus 7 times x minus 7. I end up here with, looks like 25. So this is x minus 7 squared is equal to 25. I'll square root both sides, and I get x minus 7 is equal to plus or minus 5, which gives me 7 plus or minus 5. I know 7 plus 5 is 12, and 7 minus 5 is 2. So I get values of 12 and 2, which means this actually would have factored. And you'll see what multiplies to 24 and adds to negative 14, that's x minus 12, x minus 2. Like I said, this is just another way to go ahead and solve a quadratic. It really helps when the quadratic doesn't factor. Clearly when it factors, I'd go ahead and factor unless they tell me to complete the square. So here's a situation where my first condition is not met. I don't have a coefficient of 1 in front of my squared term. So what I'm going to do is divide every term by a value that will make my coefficient in front of my x squared equal to 1. So that's dividing every term by 3. Thus I have x squared plus 6x minus 1 is equal to 0. Next, I'll isolate my variable terms. I'll take half of my b term and square it, which will give me 9. I'll then add that to both sides of the equation. I'll get x plus 3 times x plus 3 is equal to 10, or x plus 3 squared is equal to 10. Go ahead and square root both sides from here. Get plus or minus root 10 is equal to x plus 3. Isolate x, so x equals negative 3 plus or minus root 10. And that's my solution. So the thing that is complicated about completing the square is when you have a middle term or a b term. I call b term my middle term. B term that's odd. If it's even, no big deal because I'm dividing by 2. But when it's odd, you'll notice, let's go through our steps. I have x squared plus 7x equals negative 2. Now I've isolated my variable terms. Then I take half my b term and square it. Well, half of 7 is 7 over 2 squared is equal to 49 over 4, which isn't so pretty. So now, I'm going to bring this over to here. I have x squared plus 7x plus 49 over 4 is equal to negative 2 plus 49 over 4, or x squared plus 7x plus 49 over 4 equals negative 8 over 4, which is the same as negative 2, plus 49 over 4. Now, this term right here is supposed to be a perfect square. So what multiplies to 49 over 4 but adds to 7? Well, the beautiful thing about that is your answer is always the term that was half of b. So if I say x plus 7 over 2 times x plus 7 over 2 is equal to, that's 41 over 4. Notice 7 over 2 times 7 over 2 is 49 over 4. And 7 over 2 plus 7 over 2 is 14 over 2, which is 7. So this multiplies to 49 over 4, adds to 7. So I have x plus 7 over 2 quantity squared equals 41 over 4. Square root both sides. Again, this is a little messy. So in this case, I have x plus 7 over 2 is equal to square root of 41. I'll put my plus or minus. But the square root of 4 is just 2. So notice when my square root is only in the numerator. Therefore, when I isolate, I get x equals negative 7 plus or minus the square root of 41. Since my denominator was the same, I can put them both over 2. So that is the drawback to completing the square when I have a b term that's odd. If the b term is even, completing the square is a piece of cake. So we've got. Write your lesson summary, answer the questions below, and we'll get back to you.